Hello, my name is Tenario Powell. I'm doing my research design proposal presentation from Middle Georgia State University. My topic will be the role of English language proficiency in linguistics and programming problem solving. My introduction: programming involves analytical and linguistic processing. English-based syntax influences comprehension, need for SLR due to fragmented research, and limited qualitative studies on lived linguistic challenges. Me being a programmer for 20 years, I understand the correlation between English, between linguistics, and between programming. Being a writer and also being a programmer, they kind of go hand in hand together. Why language matters in programming. Programming language embed English vocabulary. You have some verbose languages like Visual Basic, and you have some other languages that are easy to read, such as Ruby. Learners must interpret syntax, documentation, and error messages that is the same from reading from left to right or from right to left in some languages. Like, instance, if you're doing Objective-C, you read from right to left. If you're doing object-oriented PHP, you read from right to left. If you're doing Java, you read from left to right. So it all depends on what you're trying to do. Language proficiency impacts debugging and collaboration, which I've seen over the years. My problem statement: programming resources primarily designed for English speakers. So the more you're dealing with linguistics, the more you can program better. That's the reason why I could go from a PHP to a Java to a C sharp to a C++ to a Visual Basic, kind of like a linguist of programming. Learn to translate and interpret technical language, so that's reading documentation and whatnot. Cognitive and linguistic challenges hinder problem solving. So when you have a cognitive and a linguistic challenge, it hinders the problem solving process. Gap: limited qualitative insights into real experiences. Gap analysis: language bias in CS education. So what I've come to see as I work with different ethnicities and different nationalities is that there is bias in CS education. The cognitive load theory shows linguistic strain increases extraneous load. Persistent inequities for ELA learners need consolidated evidence. And that's what we're going to get with the SLR. The purpose of study: synthesize and evaluate research on English proficiency and programming, which I will do with my experience with the SLR and gathering information and doing a Prisma SLR. Identify cognitive, linguistic, and instructional challenges, analyze methodical trends, and develop recommendations for inclusive programming. Research question: how does proficiency influence comprehension and problem solving? I will be able to answer that as well with my experience, also with the SLR. What linguistic and cognitive barriers exist? What instructional strategies support EAL learners? Objectives: a structured database search, a transparent screening, a qualitative coding and synthesis, develop conceptual framework, and identify gaps and recommendations, which I will do with the SLR. The proposal organization: I have the introduction, the literature review, the methodology, the findings, the discussion, and the conclusion. Preliminary review overview. I just saw an error on the last slide that I forgot to mention, but I'll get to that later. Programming requires English comprehension. In my experience, the better you know grammar and whatnot, you can program better, because there's two types of programmers. You got memory programmers that remember stuff, and grammar programmers that can interpret the grammar of the language and make it do what they want it to do and manipulate it. Error messages rely heavily on English grammar. Documentation complexity adds cognitive burden. English proficiency and problem solving. Vocabulary and grammar comprehension affects code interpretation. I've seen that in my 20 years of doing this. Low proficiency increases mental translation. Debugging challenges stem from misinterpreting keywords. So you have your keywords, your verbs, you have your sentences, and your statements inside a program. So you can think of a statement as a sentence, and a block of code as a paragraph, and a whole class as a paper. Cognitive load in programming. Complex language increases extraneous cognitive load. Cognitive overload reduces efficiency. ELA learners struggle with verbose explanation. As I said, some languages are very verbose, some are not. If you have a verbose language, being excellent in grammar and writing, that helps out a whole lot. I have a student who wrote a book He was excellent in flow charting, and he caught on very quickly right out of high school because he knew how to write. Was he written a book, and he knows the English grammar and whatnot. Linguistic barriers, misinterpreting conditional and comments, that happens a lot. Difficulty understanding documentation, and challenges decoding compiler messages. So you have compiled languages, and you have interpreted languages such as Python and whatnot. You have compiled languages such as Java, C Sharp as well. Cognitive barriers, working memory overload. That's why I say memory versus grammar. Memory, they remember what they do and take points from other programmer, but the grammar programmer, he knows the grammar of the language, he can manipulate it, he can do the processes, he can do the inputs, the outputs, and whatever he wants to do with iteration as well. Intrinsic load from new terminology, algorithmic reasoning strain. Social barriers, peer comparison, classroom anxiety, and stereotypes about belonging. That's very true about stereotypes about belonging. What I come to notice that the percentage of programmers vary very much in this field. But with AI, that has increased rapidly. LMCLP coding framework, linguistic meditation, cognitive load effects, problem solving behaviors, and supports cross study comparison. Cross study comparison. That's very important. That's what I'm going to look at in problem solving behaviors as well inside of my SLR. Research methodology, systematic literature review, Prisma guided structure, database search, screening, and synthesis. Prisma framework, we're going to identify, screen, assess eligibility, include, ensure rigor, transparency, and replicability. Research design, qualitative thematic synthesis, extract patterns across studies, evaluate empirical evidence. Well, I'm not going to say empirical evidence, it's going to be systematic evidence. I caught that error as well. Barriers, categories, table summary. Cognitive, memory limits and complexity. Linguistic, proficiency, translation, and comprehension. This is what I'm mostly going to focus on in social, anxiety, belonging, and peer dynamics. Search strategy databases. I'm going to use the ACM Digital Library, IEEE, Explore with the IEEE format. I run papers like that. Science Direct, Springer Link, Google Scholar, which is a big one, and ERIC. Search screens, English language proficiency in programming problem solving, programming comprehension in English, software debugging and language barriers, code reading and second language learners, linguistics and computer science learning, computer programming and linguistics. This is going to be the big one. Inclusion criteria, peer review from the year 2000, new millennium to 2025, programming in English focus and qualitative findings. Exclusion, non-computer language studies, opinion pieces, not in English and not full text accessible. So they'll be accessible as well. Screening process, title screening, abstract review, full text evaluation, and Prisma documentation for transparency. Data extraction, here's another editor with the bullet points. Study metadata, measures of proficiency, programming tasks, cognitive linguistic findings, and recommendations. Data analysis, thematic synthesis, coding patterns, identify relationship between constructs, and create conceptual model. Quality appraisal, CAP checklist, assess rigor, credibility, and transferability, identify method, methodological weaknesses, ethical considerations, literature based, no human subjects, proper citation and reporting transparency, which will be very important. Limitations, publication bias, language measure inconsistencies, access limitations, and variability in study methods. In the conclusion, the English proficiency shapes comprehension and debugging. Cognitive load is significantly impacted, need more qualitative and multilingual research, and provides direction for inclusion programming education. So this is going to be my research. This is what I'm going to research on with programming and problem solving. I will extend this research later in my career with AI as AI booms and continues to grow exponentially. And that is it.